Alright, so in this question what we are given, we will be given two strings. We are naming them S1 and S2. So in the string what we will be having, we will be having some characters. They may be equal or might not be equal. So suppose S1 is, let's say, B, M, C, and S2 is, suppose, let's say, B, C, M. Okay, and we need to make the strings equal. So suppose S1 is BMC and S2 is BCM. So we need to make the string equal. Okay, that is the problem. We need to make S1 equal to S2. By how? There are another constraint that is given, constraint or condition that is given. What is that? That is saying that to make the string equal, we need to delete the characters, some of the characters. So in our case, we can see that, okay, if we delete M from here and M from here, both the strings are going to be BC. Or okay, so if we delete M from here, here we are going to get BC, and here also we are going to get BC by deleting M from both the sides. Okay, so suppose if we delete M from here and M from here, we are going to eventually get BC. And suppose instead of deleting M, you would have deleted C, then also we can make both the string equal. Okay, by deleting C or by deleting M, we can make both the string as either BC or BM. So which one to delete? Either C or either M, but which one do we need to choose? So that's the thing, that if we are having two options, then it's better to choose the one that has the lower ASCII value. What does ASCII value mean? So either every character has a ASCII value. So A has always ASCII value less than B, less than C, less than dot 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 Z. Same way for uppercase character also, A has ASCII value less than B, less than C, less than Z, and dot 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 uh, sorry D dot 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 Z. So this one is small z. Okay, so from here we can see that we need to always make the string equal. That is our main target. Even if the string contain different element, suppose BCD and PQR, then we need to delete all of them. We need the strings equal no matter what. Even if they are empty strings, then also they are equal. So that's the case. So if we look at the previous example, BMC and BCM, we can essentially see that we have two options to delete, either M or either C. So which one to choose? So in the problem statement we are given that we need to choose the one that has the lower ASCII value. If we have option to choose one, then we need to choose the one with the lower ASCII value. So in our case we are going to delete C. So that's the problem. Okay, so how can we solve the problem? So the first thing that you can notice is that we have the option of deleting M also, but why we are not deleting M? Because if we delete M, then the ASCII value of M is also going to be added to the answer. And also we need to delete C, and suppose we want to make this both the string empty, then also we need to add that to our answer. So adding all of them to make the string empty is going to be much more if we have chosen to delete only C, because in that case also we are getting both the string as equal. So that's how we need to optimally find a way to choose which character to delete from the string to make them equal. So as we are getting optimally the term optimally, so suppose if we want to look at it in a way uh, from very top view, then we can see that we need the longest common character that are there, and we need the character to be of maximum ASCII value possible. So m has greater ASCII value than C, that's why it is still there. Suppose m, instead of m there was B, so in that case m has to be deleted. uh, so that's how we can see that which one we need to delete and which one to not. So by saying that, we can proceed to our next observation, that is finding the minimum ASCII value character that need to be deleted. So if you have done that problem of longest common subsequence, then you might be recalling that in that case we had two options for a string. Suppose a string is containing a, b, c, and a string is containing another string is containing b, c, d. So in that case we had two options. If both the character are not equal, then either we can check this character with this character or this character with this character. So we can use that thing in our case also. How? Let us see. So we can say that, okay, this is same as the longest common subsequence problem, but in our case we need to optimally find the maximum ASCII, the minimum ASCII character that need to be deleted. So we eventually need to find minimum ASCII uh, characters that we can delete, and it is same as saying that we need to find that at the last we are going to have the maximum ASCII values. So if we are having the maximum ASCII values, then we can say that we have deleted the minimum ones, same as that. So suppose there is two string a, b, c and m, d, c. So if two of the character are equal, we are going to take that in our ASCII value that are going to be common in both the cases. So we are going to add the ASCII value of that character plus what can be obtained from that. Let's suppose there is a recursion function of the remaining one. So how can we do that? Suppose the length of this is n1, and this is same as longest common subsequence problem. The length is n2. So if at any time string 1 of n1 is equal to string 2 of n2, then we are going to say that, okay, we need to add that to our answer plus we are going to call the same function again. And for n1 minus 1 and n2 minus 1, and if both of them are not equal, then we are going to call the function for n1 minus 1 and n2, and n1 and n2 minus 1, just like longest common subsequence problem that we have already done. Maybe you have done, or I would recommend you to do that first to understand this problem better. Okay, that's all for this problem. I hope you are able to understand.